So if you're ready to move on to the systems of linear inequalities special cases practice, I'm going to model 1 and 4 on your practice problems. So you see a trend, I bet you see a pattern, so you can write the pattern right out here for our special cases, and you follow the steps that are on your note card. So we see here that for the first inequality in number 1, the y-intercept is 0, -1, and we begin with the b because these are in y equals mx plus b form, slope-intercept form, and -1, 0, -1 is right here. And then the slope is -4/3. I always put the negative up top, and that makes the bottom stay positive. And so we would go down 4 units, 1, 2, 3, 4, and over 3 units in the positive direction. Make a point right there, and then we would go in the opposite direction to make a point here. This inequality is greater than, and it doesn't have a solid line, so it gets a dashed line on the graph because the inequality isn't equal to, and then it's greater than, so we would shade above our boundary line. Then we do the same thing for our next inequality. We see the y-intercept is 0, -2, so we would plot our point at -2, but then the slope is the same. So the negative goes up top with the 4, the 3 stays positive, and I can go down 4 units and 3 units over, make a point here, and then go in the opposite direction. This inequality is greater than or equal to, so it has a solid line, therefore it gets a solid line on the graph. We draw these lines as neat as possible. We see that they are parallel on the graph and in the equation because they have the same slope. If these lines continued forever, they would never touch. This inequality is greater than or equal to, so we shade above again. And then we see where our shading intersects because it's darker. And then you can see here that it's going to be in the shaded intersection part, but I want you to talk about why are there no solutions on that line? Why are there no solutions on this boundary line? So answer that question. You can pause the video, but answer that question, and then we will look at number 4 together. So in number 4, we can see here that the slopes are the same, they're -3, and they have different y-intercepts. The first y-intercept is 0, -3 for this -3 right there, -3, and then it's -3 for a slope, which is -3/1. And so I would go down 3 units, go over 1 unit, make a point here, and then I can go in the opposite direction to make as many points as possible. This is a less than inequality, but it doesn't have a solid line in the inequality, so it does not get a solid line on the graph. We connect our points with a dashed line and shade below because it is less than. And then we do the same thing for the other inequality, except that the y-intercept is 0, -2. So we plot our y-intercept. We can do this in a different color. In green, 0, -2, but it has the same slope. So we go down 3 and over 1. We go in the opposite direction. And we can connect our points with a with a solid line, because this one has a solid line in the inequality, it can be equal to. So we would connect these with a solid line. We see as we connect our points that these are parallel again. This is a greater than inequality, so we're going to shade above our inequality. And then we see a difference in all of the other graphs from this one about where or our solutions are, where they aren't. So I would like for you to answer this question: where are the solutions, if any? If none, then why? Why are there none? So you can pause the video or stop the video to answer these questions and do the rest of the practice problems.